Namaskaram. This is the part 4 of matrices. In this video, we will cover other important concepts of matrices, equality of matrices, comparable matrices, trace of a matrix. So now let's start with equality of matrices. Now you will be noticing that we have written a matrix like this. Why? This is the general notation of a matrix in which Aij represents each and every element of this matrix with respect to I and j, where I and j stands for position of the element in the matrix. Equality of matrices. Two matrices A is equals to Aij and B is equals to Bij are said to be equal, that is A equals to B if and only if A and B are of the same order and elements in the corresponding position of two matrices are equal, that is Aij is equals to Bij for all I and j. Now let's see this example. These are two matrices given with the condition that A is equals to B. Then it means by definition that corresponding elements of the position A11 are equal. That means A is equals to E, B is equals to F, C is equals to G and D is equals to H, as we have here. Now coming to comparable matrices. Two matrices A is equals to Aij of order m by n and B is equals to Bij of order p by q are said to be comparable, or these two matrices can only be compared if they are of the same order, that is m equals to p and n equals to q. Now take two pairs of matrices AB and PQ and tell which of them is comparable by seeing order of these matrices. The order of this matrix is 2 by 3, 2 by 2, and 3 by 2, and 3 by 2. Yes. Thus we see that the order of A and B is not equal, whereas the order of P and Q is equal. Thus P and Q are comparable matrices, whereas A and B are not comparable. Now let's come to another important component of a matrix, that is trace of a matrix. It is the sum of principal or main diagonal elements. So simultaneously a non-square matrix does not have a trace. The trace of a matrix denoted as TR of matrix A, B, C up to Z. Now let's try to find the trace of some matrices, as trace is nothing more than the sum of diagonal elements. So see the diagonal elements first. Here 1 and 6 are the diagonal elements of A. So trace of A is 1 plus 6, which is 7. Now what is the trace of B? The trace of B is minus 1 plus 1 plus 2. Minus 1 plus 1 plus 2, which is 2. Now tell the trace of C. Does it exist? No, because it is not a square matrix. So trace of C does not exist. This is all. Thank you.